Moving on, we're talking about algebraic expressions now. Algebraic expressions, would be a mathematical phrase that is made up of numbers and variables. So sometimes algebraic expressions can just be numbers, sometimes they can just be variables, sometimes they're a combination of numbers and variables doing different operations such as addition or multiplying. And so there's just all sorts of different things that can be algebraic expressions, but they never have equal signs because then they'd be equations. Let's talk about the substitution property because we're going to be using that here in our examples coming up. So if A equals B, if one thing equals another thing, then A may be replaced by B in any expression. So it's saying we could substitute one thing out for another thing if they're equivalent. It's very similar to what we see in sports for one position substituting in for another. For example, if I'm coaching soccer, like I previously did, then if I substitute out a goalie, I'm planning to put in another goalie because those are equivalent positions, a goalkeeper to a goalkeeper. I'm not planning to put in a striker or a forward, the more offensive players, for a goalie, or a goalie in for more of the offensive players either. And they play the same role as what it would have before. Evaluating expressions. To evaluate an expression with variable replacements, what you do is you substitute, like we were just talking about, the variables with the given values. Each time you substitute a variable with a number, put parentheses around it. That's going to help you have a higher chance of getting these problems correct. And then next, make sure to follow the order of operations to evaluate or simplify it. Evaluate or simplify just means kind of work it out as much as you can to where there's no more parentheses or fractions or operations. So these are going to be basically the same type of examples as we just saw with an added step. So instead of starting with just numbers here, now we're starting with variables, and we're supposed to evaluate it using the variables that we're told. So we're told here's the expression, and then here's additional information. We're told A is 2, B is 4, and C is 7. So since A equals 2, we could just as easily write 2 in place of A. And since B is 4, we could just as easily write 4 in place of 2, or in place of B. Now notice here, when I did that, A and B were multiplying. 2 and 4 are multiplying, so they're fulfilling the same jobs. B was being raised to the power of 2, 4 is being raised to the power of 2. The only things that changed was what is being squared or what is multiplying, but what I substituted in are still fulfilling those same roles. Plus C is 7, so plus 7. Now you might be wondering, why do we have all of these parentheses? They seem unnecessary. The answer is that some of them are. However, some of them are incredibly necessary, which is why I encourage you to put them around all of them and then remove them as you find they might not be necessary. Here we end up doing 4 squared before multiplication would happen, so now we just use the order of operations like we did before. So we have 2 times 16. Now here, between 2 and 16, I really only need one of them to be in parentheses, so that way I know they're multiplying together. If I put them both in parentheses, that's fine. Or I could also, if I wanted to, put a multiplication dot between them. So whether I put a multiplication dot, put one in parentheses, put the other one in parentheses, put them both in parentheses, doesn't really matter at the end of the day. Because no matter what, we're going to be multiplying them. Plus 7. Once again, if I put 7 in parentheses or not, it doesn't impact how it adds. Now, it was important that I had that at the beginning so I knew they were multiplying, and I knew I was squaring just the 4, not the 2. And it also will matter, especially when you have negatives that you're plugging in. So if one of these was like a -2 or a -4, it would end up mattering. So you have to be careful with those. But I encourage, once again, to plug it in parentheses all the time to be safe. So order operations wise, next comes multiplication. So 2 times 16 is 32. And 32 plus 7 is 39. Number 2, we're plugging in x as -2. So 3 times -2 being squared minus 4 times -2. So here's those negatives I was talking about. It comes into play here because -2 squared means -2 times -2, like we talked about earlier, which is +4. So 3 times +4. And here we end up having, sorry about that, -4 multiplying with -2, which creates a +8. Now, you might wonder, wait, why is he calling that a -4? I thought it's -4. Here's the secret. It's the same thing. I don't know why my screen did that again, but it's the same thing whether it's a minus a number or a negative number. They're really, truly equivalent. Let me showcase why. If I would have done this minus and left it alone, and then do 4 times -2, I'd have -8. Well, guess what? I ended up with 2 negatives in a row, and like we mentioned earlier, when there's 2 negatives in a row with nothing between them other than potentially parentheses, it's really adding it. So either way, whether I regarded this 4 as positive and subtracting that +4, or I regard this as a -4 and I take the sign with the number, I got the same result. So here I do multiplication next, and I get 12 plus 8, and 12 plus 8 is. Moving on to number 3, just continuing to do the same exact stuff on these next problems. So number 3, a squared b minus b squared, if a equals 3 and b equals -4. So 3 squared instead of a squared times -4 instead of times b, minus -4 being squared instead of b being squared. Once again, important to note the -4 is inside the parentheses, so that'll affect when we square it. 3 squared is 9 times -4, minus -4 times -4 is a +16, so there's only one minus sign left between the two rather than 2 minus signs creating a positive. Multiplying gives us -36 minus 16, and combining those two negatives gives us -52, a bigger negative. Number 4, a squared b minus b squared again, but now a and b are different numbers. So let's try this out. 4 squared times -7 minus -7 being squared. So this time again, that -7 is inside the parentheses with the negative there. So we get 16 minus times -7, my apologies, minus 49. Once again, a positive number coming out of this with the minus sign before it. 16 times -7 is -112. Subtract 49 from that, and we end up getting -161. Because there's 2 negatives, they once again add together to make a bigger negative. Number 5, -y squared minus 3xy. So this negative is unique. This negative is outside the y squared, meaning we're going to, I don't know why my iPad just glitched, but that's fine. So meaning we're going to have negative, then whatever y is, and square it. So regardless of what happens here, we're going to end up having a negative result from that part because the negative happens outside the parentheses. Minus 3 times -4 times 2. So this ends up being -4. -3 times -4 is +12. And that's going to multiply with 2 again as well. So you have -4 plus 24, which gives us +20. When they're different signs, negative and a positive, they subtract, and you keep the sign of the bigger number. 6, -y squared minus 3xy again, but the numbers are different, including one fraction. So negative of -12 being squared minus 3 times negative 5 over 6 times negative 12. So negative 12 being squared is positive 144, but this negative out here tells us to make it negative now. Here, I'm going to put this negative 3 over 1 and the 12 over 1 so we can start cross-reducing. We can cross-reduce this 3 and this 6, for example. So 3 and 6, 3 goes into 3 once and 3 goes into 6 twice. However, I can actually cross-reduce this 2 with this 12 too, or this 12 as well. And so the 2 becomes a 1 and the 12 becomes a 6 because 2 goes into 2 once and 2 goes into 2 goes into 12 6 times. But it was negative, so it stays negative, just like this 1 up here would stay negative as well because the 3 was negative. Now as we multiply straight across, we have negative 1 times negative 5, and it'll be times negative 6. So if I just do 2 of those at a time, negative 1 times negative 5 is positive 5 times negative 6. Next, I'll have 5 times negative 6, so negative 144 minus 30. Combining those gives us negative 174. Moving on to the next page. More of the same as we continue forward. A squared plus b squared over a minus b. So we have 3 squared plus 4 squared over 3 minus 4. On the top, 3 squared is 9, and 4 squared is 16. On the bottom, 3 minus 4 is negative 1. On the top, 9 plus 16 is 25 over negative 1, which is just negative 25. Number 8, same verb or algebraic expression, but different values for a and b. So we have negative 3 squared inside parentheses, negative 5 squared inside parentheses. On the bottom, we'll have negative 3 minus a negative 5. Note there's 2 negatives, one from the minus sign and one from b equaling negative 5. On the top, negative 3 being squared is positive 9, and also on the top, negative 5 being squared is positive 25. On the bottom, when there's 2 negatives in a row with only a parenthesis or nothing else between them, we make them positives. So we have negative 3 plus 5, which is positive 2. 9 plus 25 is 34, and 34 divided by 2 is 17. Moving forward, number 9, let's plug these in. So 2 for x, so 2 squared minus 2 times 2 minus negative 2 minus negative 3 being cubed. So 2 squared is 4. I can go ahead and do that since the only operation next to it is minus sign. Then inside the parentheses, we have 2 negatives in a row, so that'll be adding, and 2 plus 2 is 4. Here, minus negative 3 being squared, we discussed that earlier. Negative 3 times negative 3 times negative 3 is a negative 27. That gives us 2 negatives in a row. They'll really become a positive. Next, we're going to do this negative 2 times is 4, taking that sign with the 2 for the purpose of multiplying. And we get 4 minus 8 plus 27. From left to right, we do 4 minus 8 is negative 4, and negative 4 plus 27 is 23. Number 10, same variables, but now the variables are different values. So we have negative 3 being squared, minus 2 times negative 3, minus 4, minus negative 1 being cubed. Negative 3 squared is negative 3 times negative 3, which is 9, minus 2 times whatever's in the parentheses. Negative 3 minus 4 more is negative 7. Minus negative 1 cubed is negative 1 times negative 1 times negative 1. Negative 1 times negative 1 is positive 1. But if we multiply that by another negative 1, we end up getting -1 again. So we have two negatives in a row there, one from the minus sign and one from the -1 being cubed. That creates two positives. So now we multiply this -2 times -7, and we get 9 plus 14 plus 1. Adding these together from left to right gives us 23 plus 1, and then 24. Number 11, start plugging these in. Negative of -2 being squared minus 2 times 3 times -3 minus the absolute value of -3. So here, -2 being squared is +4, but this negative outside still exists, and so we make it -4. From left to right, -2 times 3 is -6, still multiplying with a -3, minus the absolute value of -3 is +3. Next, we still have this multiplication, so I'm going to rewrite -4 as we're not using it yet, but -6 times -3 is +18, minus that 3 still hanging out. -4 plus 18 from left to right is 14. Subtract 3 from that, and you get 11. Number 12, plugging in -3, -5, and 2 instead. So we have negative of -3 being squared minus 2 times -5 times 2 minus the absolute value of 2. So we have -3 being squared is +9, but we still have this negative, so it's -9. -2 times -5 is +10 times 2 still, minus the absolute value of 2 is +2, so just -2. Multiplying 10 times 2, so we have -9 plus 20 minus 2. -9 plus 20 is 11 minus 2, which gives us 9.